Hey listeners, are you ready to uncover some extraordinary wonders? Disappearing Spoon is thrilled to partner with the amazing Curiosity Box. It's a science subscription service for curious minds. It's created by Vsauce, the internet's leading science education channel, with over 3 billion views. This season's box is packed with goodies that will fascinate and inspire you. Challenge yourself with a magnetic shadow alphabet puzzle. Piece it together to spell out the alphabet using only the letter shadows. Or discover the picture pot, where art and mathematics merge into a colorful, creative masterpiece. It is fun and educational. And the highlight, a sample of recreated Martian soil. Experience the thrill of holding the red planet right in your hands. Don't miss out on this unique adventure. Subscribe to Curiosity Box now and celebrate the incredible achievements of science. For 50% off, use the offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon. That's offer code SPOON at the-curiosity-box.pxf.io/disappearingspoon for 50% off today. Unbox the mysteries of the universe with Curiosity Box. When the barometer shattered, Auguste Piccard could only watch in horror as mercury spilled everywhere. Piccard and his assistant were floating several miles in the sky in a metal shell dangling beneath a balloon. Unfortunately, that shell was aluminum, and mercury is not only poisonous to breathe, it also eats through aluminum like acid. If Piccard did not figure out how to clean up that mercury, and fast, a hole would open up in the shell. All their precious air would rush out. They would suffocate in minutes. And there was more at stake here than just Piccard's life. He had ascended that day to run some experiments with big implications. This work could firm up Einstein's theory of relativity, and according to some people, it would reveal the fate of the cosmos, and even whether God existed. But to do all that, Piccard first had to survive this flight. It would not be easy. But in doing so, Piccard would live up to his future namesake in boldly going where no man had gone before. From the Science History Institute, this is Sam Keane and the Disappearing Spoon, a topsy-turvy, science-y history podcast, where footnotes become the real story. Auguste Piccard was born in Switzerland in 1884. He stood 6'6", with a body like a cornstalk. He looked like a happy Edgar Allan Poe, with tufts of hair sticking out and a gaunt, mustached face. Even among scientists, Piccard was considered kind of eccentric. He never went anywhere without a slide rule and 2 wristwatches. That way he could tell if one was off by checking it against the other. He also decorated his home with prisms to cast sunbeams everywhere inside. But he was a brilliant scientist, and quite famous. He was friends with Albert Einstein, who served on his PhD committee. He inspired the beloved Professor Calculus from the Tintin comics. Piccard was also the inspiration for a certain character on Star Trek.
I'm Captain Jean-Luc Picard of the Federation Starship Enterprise.
I hereby formally request third-party arbitration of our dispute.
Piccard was inspirational because he was no armchair scientist, just sitting around at home. Despite his gangly frame, Piccard served in the Swiss military, in fact in their balloon corps. And he realized that his ballooning skills could help him answer some pressing questions in physics. One question involved the Michelson-Morley experiment we heard about in the first episode of this 3-part series. In 1887, in Cleveland, Michelson and Morley measured the speed of light, and they found that the speed was the same no matter what direction they traveled, which did not make much sense. That finding also violated Newton's laws of physics. Overall, the Michelson-Morley experiments were a big mystery in science, and a big embarrassment. For decades, no one knew how to explain their results, until Einstein came along. There's no time to get into all the details here, but Einstein proposed that light always travels the same speed no matter how you measure it or what direction you're going. He also proposed that light was the universe's ultimate speed limit. Nothing can go faster than light. All the bizarre effects of relativity you might have heard about are consequences of light's constant speed. The twin paradox, the interweaving of space and time, the fact that time slows down the faster you move, the constant speed of light explains all those things. It's a fundamental feature of how the universe works. But not everyone appreciated Einstein's insight. In fact, his ideas struck some people as spooky, even blasphemous. Time can slow down? The universe had a speed limit? Newton was wrong? How can that be? So, certain scientists set out to disprove Einstein. Mostly they failed. But in 1921, the American physicist Dayton Miller reran the Michelson-Morley experiment on Mount Wilson in California at an elevation of 5,700 feet. And according to Miller, at that elevation, the speed of light varied. Which was a big deal. Einstein built all of relativity on the invariant speed of light. So if light speed actually varied, Einstein was in trouble. Now, Miller's announcement left Einstein furious. He felt certain that Miller was wrong. It made no sense for scientists in Cleveland to get one result and scientists in California to get a contradictory result. As he said about Miller's work, subtle is the Lord, but malicious he is not. Still, Einstein could not insult Miller publicly. It wouldn't be gentlemanly. And Einstein was no experimentalist. So he had to turn to his disciples to defend his honor. Disciples like Auguste Piccard. Miller claimed that the speed of light varied at higher elevations. Fine, Piccard said. Let's elevate things even more. Let's rerun the experiment in a balloon. In 1926, Piccard ascended in a balloon to 15,000 feet. And when he reran the Michelson-Morley experiment there, he found no variations in the speed of light. Miller was dead wrong, and his reputation was disgraced. Meanwhile, Einstein was thrilled. He sent Piccard a personal letter of thanks. But Piccard wasn't satisfied to stop there. People were still questioning Einstein's work. And then even wilder ideas started burbling up about so-called cosmic rays and their possible connection to God. Cosmic rays are streams of particles from deep space. Delightfully, they were first discovered atop the Eiffel Tower when scientists noticed some electrical equipment up there going haywire. Cosmic rays stream down from space by the trillions, a constant invisible rain pelting the Earth every day, every second. They're pelting you right now. So what are these particles? That was the controversy. One group of scientists thought that cosmic rays were just regular old subatomic particles raining down from space. Protons, electrons, stuff like that. Other scientists proposed something radical. They said cosmic rays were photons, bits of light. And the radical part was the source of these photons. They claimed that these photons were new atoms being spontaneously generated in space. In fact, they said these new atoms being born gave rise to new stars. They actually called cosmic ray photons the birth cries of stars. And there was more. Many scientists then were grappling with something called the heat death of the universe. According to the laws of thermodynamics, all matter in the universe will eventually dwindle to the same freezing cold temperature, at which point life will be impossible. This heat death won't happen soon, but thermodynamics says it will happen inevitably someday. Some scientists, however, hated the idea of the universe dying, especially those with a spiritual bent. The death of the universe seemed cruel, it seemed pointless. So they proposed that atoms can wink into existence from nothing. And if new atoms were constantly being created, new stars and new planets could form. Life could go on. Cosmic rays were therefore the birth cries of life itself. Now, the talk of creation from nothing, of course, provokes thoughts of the prime mover, the big cheese, God. In fact, newspapers made that connection explicit. If cosmic rays were photons, they said, that was scientific proof for God. And those scientists with a spiritual bent? well, they encouraged that line of thinking. So, yeah, the stakes were pretty high here. People thought of cosmic ray research as a way to study the existence and very nature of God. Things really heated up when a Dutch scientist found preliminary evidence that cosmic rays were less abundant near the equator and more abundant far north. This was a big deal. If cosmic rays were regular old particles like electrons and protons, they would have an electric charge. And if they were charged, the Earth's magnetic field would pull them toward the poles. More to the point, since photons have no charge, cosmic rays that were attracted to the poles could not be the birth cries of stars. Now, that Dutch scientist only got preliminary data. So a team of 60 scientists decided to spread across the globe to measure the number of cosmic rays at different latitudes. This was actually the largest scientific mission in history to that point. And it was not easy work, especially at the poles. You can hear more about this dangerous mission in a bonus episode at patreon.com/disappearingspoon. In fact, 2 scientists died on this mission, but not before heroically gathering their data. That's patreon.com/disappearingspoon. When the polar mission wrapped up in the early 1930s, there was clear evidence for a higher number of cosmic rays near the poles. It seemed like case closed. Cosmic rays were charged particles, not photons. Unexpectedly, though, the spiritual scientists parried. They said, sure, there might be more charged particles near the poles, but they denied that those particles were cosmic rays. Instead, they claimed something else. They claimed that the photons, the birth cries of stars, were streaking in and colliding with air molecules in the upper atmosphere. These collisions supposedly shattered the air molecules and released other particles that happened to be charged. And it was these secondary particles that the polar mission had found. Overall, then, the godly scientists said that the mission to measure charged particles had not proved them wrong. To the contrary, it proved them more right than ever. This twisting of the evidence made the other scientists gnash their teeth in anger. They realized that the only way to win the argument would be to measure cosmic rays directly, and to do so high in the atmosphere, before they supposedly collided with any air molecules. And there was only one scientist on Earth with the technical and aviation skills to pull that off: Auguste Piccard. To measure cosmic rays, Auguste Piccard would need to ascend higher than any human being ever had, 14 miles into the stratosphere. Several scientists begged Piccard to abandon this plan as suicidal, but the namesake of Jean-Luc Picard was not easily dissuaded. In the stratosphere, there is 90% less air than on the ground, so Piccard designed a pressurized aluminum sphere for the ascent. He called it a gondola. It was 7 feet tall to accommodate Piccard's height, but it was just 1/8 of an inch thick. The balloon itself was painted bright yellow, like a giant egg yolk. The flight took place in May 1931. Piccard planned an 8-hour trip starting from Augsburg, Germany. For safety's sake, local authorities insisted that he and his assistant, Paul Kipfer, wear helmets. Piccard and Kipfer didn't have any, so they put upside-down baskets on their heads instead. The German officials did not realize that they were being mocked and gave their approval. The flight left at 4 a.m., and it was rocky from the start. The balloon began rising at 20 miles an hour, far faster than expected. Piccard and Kipfer tried releasing gas from the balloon to slow their rise, and quickly discovered that the release valve had frozen shut. They now had no way to descend. As Piccard said, they were now prisoners of the atmosphere. Soon, Piccard and Kipfer rose so high that they became the first people to see the curvature of the Earth with their own eyes. But they didn't have much time to enjoy the view because more problems quickly arose. Piccard had painted half the gondola black and half white. A motor was supposed to rotate the black half toward the sun when they needed warmth in the gondola, and rotate the white side toward the sun when they needed to cool down. It was a brilliant idea, except then the motor failed. This left the black side of the gondola facing the sun's rays, which are intense at high elevations. So while the temperature outside the gondola was 100 below zero, the temperature inside rose to 100 above zero. Soon all the water they'd brought to drink evaporated. To quench their thirst, they were reduced to licking condensation off the walls of the gondola. And then the real danger started. They soon heard a low whistling noise, a leak in the shell. Their air was disappearing. Piccard found the hole and slapped a cloth and some Vaseline over it until the whistling stopped. He later said he never appreciated silence so much. Then the worst crisis of all arose. A barometer shattered. Liquid mercury spilled out and began eating through the thin metal gondola. Piccard tried scooping it up, but it was too slippery. It's a liquid. Piccard wished out loud for a vacuum cleaner. If only they had one. But of course they didn't. Or did they? Outside the shell was the near vacuum of the stratosphere. So Piccard got an idea. He grabbed a rubber hose on the wall. This hose was connected to a valve that was itself connected to the outside. And when he opened the valve up, the near vacuum outside sucked the mercury right up. And so things kept going. A crisis would arise, and Piccard would MacGyver some solution to it. This continued hour after hour until the sun set. Finally, the gas inside the balloon contracted in the cold. The balloon started to drop, and it crash-landed on a glacier in Austria at 9 p.m., after 17 hours in the air. After crashing down, Piccard and Kipfer began hiking toward civilization. On the way, they met a team of rescue guides who'd been sent up after them to retrieve their corpses. They assumed that no one could have survived such a harrowing journey, but Piccard and Kipfer had. For simply surviving the flight, Piccard became a celebrity, especially in aviation circles, and for good reason. His pressurized, airtight gondola inspired the modern fuselage that allows airplanes to ascend to incredible heights. We would not have modern aviation without Piccard. And the work had profound implications for science. Now, between all the times he nearly died, Piccard did not get a lot of science done on that journey. But the little data he gathered supported the idea that cosmic rays were charged particles, not the photon birth cries of God creating new stars. Later, other scientists made other balloon journeys that provided further support. They drew on Piccard's innovative designs, and they took courage in his example. In fact, their work soon provided the strongest evidence yet for relativity. Again, the God-fearing scientists had talked about photons colliding with air particles high up in the atmosphere and creating new particles. They were wrong on the details here, but they did get one tiny thing right. Cosmic rays do collide with air particles in the upper atmosphere and produce exotic new particles. These new particles are called muons. Muons are like fat electrons. After they form, they streak toward the ground. However, muons are fragile. Their half-life is 1.6 microseconds. Given that short life, as well as how high up in the atmosphere they form, most muons should disintegrate long before they reach the ground. But they don't. Scientists find gobs of muons at ground level. So how is that possible, given the distance they have to travel and their short lifespans? The answer is relativity. Muons move so fast relative to Earth that their internal clocks actually slow down. It sounds bizarre, but Einstein's relativity predicts that this will happen. It's called time dilation. And time dilation for muons remains some of the most compelling evidence we have that relativity is correct. And we can trace it all back to the pioneering work of Auguste Piccard. Piccard's combination of daring-do and scientific genius is nearly unrivaled in science history. As one observer said, it's like Einstein getting into Apollo 13. And Piccard did not stop with exploring the heavens. After his record-setting ascent into the stratosphere, Piccard got invited to a dinner with Charles Lindbergh and Amelia Earhart, a nice honor. But the oddball Piccard was most interested in talking with a fellow explorer at the dinner, a man who specialized in deep-sea diving. The explorer asked Piccard what he had seen way up in the sky on his balloon flights. Piccard thought and then answered, well, no angels. Piccard then asked the explorer what he had seen 3,000 feet down in the briny deep. No mermaids, the man answered. It was a light-hearted joke between the men. But the conversation about deep-sea exploration got Piccard thinking. That explorer had descended to just 3,000 feet, roughly half a mile. But the ocean reaches 7 miles deep in certain places. Was it possible to reach those depths? After conquering the air, Picard was itching for a new challenge, and he decided that his next adventure would be underwater, and that he would be joined by his own son. You can hear all about it in next week's episode. This is the Disappearing Spoon podcast, brought to you by the Science History Institute. Find out more about their library, museum, and multimedia magazine at sciencehistory.org. Make sure you check out the Science History Institute's other awesome podcast, Distillations. You can find their in-depth narrative stories and interviews about everything from space junk to sex, drugs, and migraines, anywhere you get your podcast, and on their website, distillations.org. You can find more incredible stories from my books at samkeen.com. You can also book me as a speaker at your school or event. If you like this podcast, please support it at patreon.com/disappearingspoon. It costs as little as 7 cents per day. You can also get bonus episodes and signed books. Please spread the word to others as well, and subscribe in iTunes, Stitcher, or other places. This episode was written by me, Sam Keen. It was mixed by Jonathan Pfeffer and produced by Mariel Carr and Rigoberto Hernandez. Thanks for listening.